It's good to come your way once again as we continue this wonderful journey in core mathematics. My name is Nanaya Wedu, and you can call me Senana. Remember to like this video, share this video, comment at the comment section, subscribe to my YouTube channel, and click on the notification bell so that you can be abreast with all videos I put out there. In our previous lessons, we've gone through lessons to look at angles and the Pythagoras theorem. And especially for Pythagoras theorem, we've looked at the right angle triangle. And we've looked at the property that helps it to be able for us to develop the Pythagoras theorem with some questions that we have also considered. In this lesson, we want to consider vectors and trigonometry. And we are zooming in and looking at an introduction to vectors. Once we are done with the lesson, you should be able to see how important vectors is in our lives, especially in the area of physics, in construction, in engineering, and in mathematics. Now, let's consider what a vector is. So basically, when we look at vectors, we are considering a line that has a magnitude, and then it also has a direction. So basically, when we consider magnitude, we are looking at the length of the line. So for instance, with this line, let's say it is from A to B, we can say that it has a length AB, right? It has a length from A to B, which we can give probably, we can say it could be 5 centimeters, right? So a magnitude just looks at the length of the line. And then when we are having this, and we are considering it as probably moving from one point to another. So for instance, you are moving from your school, which is point A, and you are traveling to a store to buy something, probably in a straight line, point B. And you know the direction which you are moving, right? We can say that you are moving from point A to point B. The length from A to B represents the magnitude. And then the direction from A to B would be how wide or how far you are moving, right? So you can either be moving towards your north, you can be moving towards your south, you can be moving towards your east, and then you can be moving towards your west. Or better still, you can be moving towards a particular angle. So when we consider this and we look at it in terms of having a line here and a line here, right, we can see that you are moving in a particular angle. So the direction represents the particular angle which you are moving. So vectors can be one of magnitude and direction. A line that has magnitude and direction, right? So basically, we can also think of vectors as traveling at a speed. So a particular speed. So we are traveling at a speed of 90 kilometers per hour and moving in a particular direction. So let's say you are moving from X and you are moving towards Y. And you are moving in a direction XY, right? And then you are traveling either north or south or east or west. Or probably you are traveling north-south or southeast or east-west. So we can consider vectors when we are looking at it in a Cartesian plane. And we know our Cartesian plane consists of our x coordinates and our y coordinates. And basically, when we have our x and our y coordinates, we can see that the vectors can move from the origin, which is our 0 and our 0. And let's say let this point be the x, and then it moves towards the direction here, and then it moves towards your y, right? So in this case, we can see that our movement is on the x coordinates, probably up to this side, and then it moves up here, and then on the y coordinates, it moves towards this side, moves down here, right? So you have our y coordinates, you have our x coordinates. So this is our vector. So our vector moves from the origin 0, 0 and moves towards y, right? So it has a magnitude where the speed is being calculated as probably 90 kilometers per hour. So a vector has a magnitude, right? So probably this could be 90 kilometers, and then it has a direction where it considers the angle which it moves through. So the angle can be represented by what? Theta. So that represents the direction of the vector. So we have considered vectors as one that moves towards a magnitude and towards a direction. So we can also define a vector as a line, right? So we can say that a vector is a line. So as we've been looking at, so we can say a line from M to N, which has a magnitude. So the magnitude, look at the length of it, right? So it has a magnitude where the magnitude represents the length, and it also has a direction, right? So we can look at the length of the line between 2 points A and B, right? So for instance, if I have my Cartesian plane and I have this A and I have that side as B, and these are X, these are Y, the length from A to B, right, would represent the magnitude of the vector. And then the direction, which is how it has moved, whether it has moved north or south or east or west, will represent that direction. So that direction can be an angle, right? So this represents our direction. So the direction or displacement, right, from the origin, how it has displaced from the origin, represents the direction of the vector AB. So in this lesson, we have basically looked at the introduction to vectors. We've considered what a vector is, and we've come to realize that a vector is a line that has a magnitude, where the magnitude represents a length, and a direction, where the direction represents the angle or probably how far or the displacement for which the vector has moved through. In our next lesson, we want to consider the representation of vectors in 2D, and then we will consider the magnitude of a vector. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.